In this video, I'm going to show you how you can calculate the equation of a line that is represented in the general form. Now consider we have a line that passes through points 2, 3, and it's got a gradient of 5. What we're going to do is firstly, I'm going to graph this so you get a visual or interpretation of what this is going to look like, and then I'll show you how to calculate how to determine the equation itself algebraically. So jumping into the graphing, point 2, 3, then a gradient of 0.5, rise over run, up 1, across 2. Alright, so what we've got here is a interpretation of what it is we're trying to find. So the graphical interpretation of what we're trying to find. Now I'm going to show you a method to deduce the general form. Now the way in which we can do this is we're going to use an adaptation of our rise over run formula. So when we're going M, we go rise over run. And another way to write that is, I shouldn't be working across the page, but it will make sense in a second. We'll go y take y1, and then we'll go x take x1, and all of that is equal to the gradient. So effectively I've worked across the page, but it's allowed us to show this form here. So effectively what we're doing is we're using the gradient formula, rise over run, to derive the general form. Now next step is we have to sub in values. And the values we have, well firstly we've got this 0.5, which is our gradient, and that's represented here. Second one is we've got our x value, which is represented by x1 here, and then we've got our y value, 3, which is represented by this y1 over here. So what we can do is we can simply substitute in these values. So subbing them in, we're going to get m as 0.5, y take 3, all over x take 2. Changing this 0.5 to a fraction, simply because it's neater that way, we're going to get y take 3, all over x take 2. Now the first step is I want to get rid of the x over 2 on the bottom, because remember, in general form we're going for something of the likes of x, so ax plus by equals c. We want to arrange it in this form. So to do that, I can't have x in the bottom or in the numerator of a fraction. So I'll move it up here, and we're going to multiply both sides by x take 2. So that's going to become, on the left hand side, y take 3 equals a half x take 2. Now next step is, it looks all well and good, but I don't like this fraction here. I don't like that 2 on the bottom. So what I'm going to do is I'm going to multiply both sides by 2. So this will give me y, or 2 times y take 3, and then x take 2. Now expanding out the bracket, we get 2y minus 6, then x take 2. Now the next problem is I've got this minus 6 on the right hand side. I don't want that. I want all of my constants on the right hand side, not the left. So I'm going to add 6 to both sides. So that will give me 2y x take 2 plus 6. And then I don't like this x over here, so I'm going to move it to the left. So that's going to give me minus x plus 2y minus 2 plus 6. Collecting like terms, I'm going to get minus x plus 2y equals plus 4. Then I'm going to multiply both sides by -1, simply because I don't like this negative in front of the x here. So doing that, I'm going to get x take 2y minus 4, and therefore yielding the equation that gives the equation of this particular line over here, represented in general form. So looking back, to calculate the equation of a line in general form, we're simply just using an adaptation of the rise over run formula M, whereby we set y take y1 being the value of the point we have, and x take x1 where we're looking at the x value of the point we have, and all of that is equal to our gradient that we're given